think we're going to go ahead and get started here. So my name is Sai Bola, and I'm a senior studying data science here at University of Michigan.
My name is Han. I'm a junior student studying business and data science at the University of Michigan.
Yeah, so thank you all for attending or joining us for this careers and industry panel. Actually, probably a good time for you all to, I guess, I'll let you guys introduce yourselves, and we'll just start with Nick.
Sure. Thanks. I'm not sure how long the intro is supposed to be, so feel free to cut me off if I'm taking too long. My name is Nick. I come from a background in statistics. I studied at McGill in Montreal. And then I went on to work at Google for about 7.5 years as a data scientist, well, statistician, sort of data scientist, although the term didn't really exist when I started. And 2.5 years ago or so, I moved on to Lyft, where I still am now. I'm now kind of managing the whole data science group here. We have about 40 people and growing. So yeah, so that's where I am today. I'll leave it there for now, and we can get into more detail later.
Cool, thank you. Anne?
Sure. Hi, my name is Anne. I graduated from Macalester College in 2013 with a degree in a degree in economics and applied math and statistics. And then after graduation, I worked at an economic consulting firm for 2 years. The company is called Analysis Group. And then in 2015, I left that job and joined Facebook and stayed there for 2.5 years until now. So my role here at Facebook, I'm an operations analyst at the small and medium business team. So our goal is to support 5 million small and medium businesses who do advertising on Facebook and Instagram. We need to provide support at scale, 5 million advertisers, so data drives a lot of our decisions here. I'll stop here and we can get into more details later.
Awesome, thank you.
Hi, I'm Chandra, and I'm from Minnesota, and I did my bachelor's in math with a minor in economics at Augsburg, and I went to lots of parties at Macalester, so good times there. Then I did a master's in stats at Columbia and a PhD in stats at Yale. And from there, I worked in the Center for Statistical Research and Methodology within the US Census Bureau, and I'm currently at Google. I've been here for like 1 year and 2 months now, and my title says Senior Solutions Consultant. I was in that role for about 11 months, and now I am a statistician on the Gmail team. And I guess we're going to do details a little later.
Yeah, awesome. Cool. Thank you guys for the introductions. So briefly, I guess before we get started, just wanted to thank our sponsors. So the American Statistical Association, the Consortium for the Advancement of Undergraduate Statistics Education, our studio, Google, and DataCamp. So thank you all for sponsoring this, and we will get started by, also to the audience, feel free to ask, or just type into the questions, and we will be watching that closely and asking those questions. Han's going to start us off with one.
Yeah, so our first question is, what advice do you have for someone interested in working as a statistician in the industry?
By the way, feel free to mix up the order with who answers first, I guess. Yeah, so I mean, advice. I guess I would first of all advise people to go to graduate school in statistics if that's not already obvious. I think that's really the best way to gain a deeper understanding of a lot of the methodology that you'll be putting to use. I would also encourage people to learn enough programming so that they feel confident in their abilities to write code, because that's one way to never be blocked and never be stuck in your job. If you can be self-sufficient in, generating data sets for yourself, and in implementing, the models that you build, then I think it's really kind of frees you to do really great things.
I'll second the programming experience comment. And then also, so I did go to grad school, but within that, I got lots of experience working with real world data, like before coming out into industry. And it was totally invaluable. We at Yale, we had this like stats clinic every Friday for a few hours, and people would come from around the university. They would just bring their data and, have questions. And I just, it exposed me to a variety of actual like real data problems, because sometimes like, in class things just work out nicely, and it's almost never like that in the real world. So just, if you can get that experience, it's invaluable.
I agree. So first of all, coding skills is really necessary because you need to get the data to work with. I did not go to grad school, so I also want to share a little bit of my experience. So I think for people who really know they want to do like hardcore statistics, like very early on, feel free to go for it, do grad school or whatnot. But if you are someone who likes working with data, who likes working with trying to solve real-world problem, but you actually don't know what does it really mean in the real world. You can still like try it. You can do internships or talk to as many as people who may be in areas you are potentially interested in. And it's okay to also just try out a few internships or work for a year or two and see what you really like, and then zoom in on what areas you identify that you want to do for longer term.
Awesome. Thank you, guys. So another question, and I guess this kind of helps learn more about what you guys do in your job. So what does a typical day look like? Briefly.
I can start. First of all, there's no typical day. I'm sure it may, but I'll share a few of the problems that we are actually trying to solve for, just to give a better sense. For us, I work on the small and medium business team. Some type of questions we're trying to answer is, how do we onboard advertisers on Facebook? Or when we are designing a new program, how do we measure the effectiveness of this program? Is it actually generating impact, generating revenue? Or if we see revenue, advertising revenue going down or growing or decelerating, what is the cause of these? So these are the type of questions we are trying to answer. So from day to day, from an analyst, you can be doing kind of zoom in on the questions, refine it a little bit, and collecting data that you need in order to answer that question. It can be, okay, you actually have your data, and it can be a day of doing analysis, or it can be once you have packaged your recommendations or meeting with different people, you want to present it to people who actually need to be involved to make decisions or whatnot. So it's a mix of doing work on yourself and also talking to different people and also influencing decision-making on the problems you want to solve.
I can go next. So I'd say a day in my life is actually pretty boring at the moment, because most of what I do is sort of people management and trying to recruit new data scientists and hiring. So that might be less interesting for this panel. I would say like I could give you sort of a day in the life of a regular data scientist at Lyft, or even myself when I was starting out at Lyft. And maybe a week in the life is more appropriate, because in a day it's hard to get anything big done. But in a week, let's say you might start out with an idea for how to improve a model or design a new model or a new algorithm. So after getting the idea, you would usually pull a bunch of data, do some exploratory analysis to see if the data, if the idea has any legs at all. If it does seem promising, you would then maybe try try coding up like a proof of concept in like a simulation environment, so slightly more realistic than an exploratory analysis. If things are still looking good and promising, you can tune your model a little bit, and then if it still looks good at that point, launch a live experiment on real users where you're subjecting half of the population, for example, to a treatment, which is your new model, and then run that for some time, and hopefully, if metrics are positive and we're having good impact on whatever metrics you care about, you'll actually ship that to all users. So that's kind of a cartoon of the kind of arc of a data science project.
So I've only been in my current role for about 2.5 months, and I'm just like trying to understand what the heck everything is. So I'm on the like Gmail backend engineering team, but within that, I'm in like the app's capacity planning. So I do like capacity planning for Gmail and other apps like Drive, and like, what does that mean? So I'm trying to answer questions like, how much computing resources do we need, like actual machines, and where, and like how much power do we need in our various like data centers, and where should copies of each user's data be, and how many copies do we need to make sure that it's always there when you need it? How much network bandwidth do we need from every location to every other location? So for me, I'm like really trying to like get the domain knowledge, like understand like network and computing, like just all of that. And then there's so much data that I was like trying to get a handle on what's there and what to like bubble up. I spend most of my day in R, which makes me happy.
Awesome, thank you.
Cool. So our next question is, what do you think makes a good data scientist?
Or statistician.
Yeah.
If there's a difference.
There's a lot of difference.
Yeah.
So I know I just went, but I don't think I've started first yet. So like, in thinking about me, like really trying to get the domain knowledge. So like one thing is like being able to speak to the people you're helping in their language. I think that's an important thing. I'm gonna think more and let the other panelists go.
Sure. I think I'm not a hardcore data scientist, but I'm doing on the data analytics role. So for me, what I think sets apart really successful one is actually everyone is actually understanding business context, trying to really know what is the problem you're trying to solve for. You can have like really fancy models and doing crazy stuff, but if it's not trying to solve for a real business problem, it actually just stops there. At the same time, once you have your question, your solution, communications is the key. You can have like an awesome solution to an awesome problem, but you cannot influence anyone to take action on the, you have to sell your ideas. You have to be able to understand what people care about, what is important about the business, and actually convince people who need to make decisions to take the decision.
Yeah, just building on that a little bit, I think business sense, communication are important, but to the point of sort of influencing others, I think the really successful data scientists I've seen are kind of thought leaders in the sense of being able to not just like deliver on a task or a project that somebody assigns to them, but actually to define what the project should be and to ask like incisive questions when they are assigned something. To try to understand if that's really the right thing to be working on. You encounter a lot of people who are like product managers or engineers who have like these ideas of what they think should be built, but then sometimes they don't have the mathematical expertise to really understand whether that's the right thing. Understanding things like uncertainty, things like overfitting, all these kinds of concepts that are actually quite subtle and in some cases take an expert to really understand fully. So sometimes the most value you can add is to like turn the question around, turn the problem around, and say, well, okay, that's one way to frame it, but have you thought about this framing instead? And I think this can lead to an actually, better solution.
Awesome. Thank you, guys. I guess another question we had, and we're still waiting on audience questions, so please type away.
I actually have a question. Can a panelist ask a question? So
Yes,
I found it
absolutely.
interesting when Anne started with, I'm not a hardcore like data scientist, and I actually had like, what is the difference between a statistician and a data scientist? Like, so I did my PhD in statistics, and now like Yale actually recently changed the name of the department to statistics and data science. But I met like data scientists along the way, and I'm like, isn't this just what I do? So like, do any of you have Nick? It looks like you're the head of data science. So do you have any thoughts on like what is the difference?
Yeah, you would think that I would know, actually, right? So this is an interesting question, and I think the right answer is that there's no well agreed upon definition. I've actually done some research this year talking to people from several companies trying to understand how they define it. And there's quite a big range. So some companies, don't even have data scientists. They just have like what they call business analysts and what they call like machine learning engineers, and nothing kind of in between. Other companies, so I can tell you how Lyft sort of defines things. So we don't have a notion of a statistician, but I would say that most statisticians would be data scientists here. What we do have is a separate group called analytics. And the difference, I would say, between what analytics does and what data science does at Lyft is that analytics team produces things for which the consumer is a human. So whether that's an executive or a general manager of one of our local markets, they'll produce like visualizations and sort of data summaries, and occasionally outputs of models and things like that, so that a human can make better decisions. What the data science team focuses on primarily is things for which the consumer is like a machine or an algorithm. So we build models and algorithms that are kind of powering all of our real-time, all the real-time pieces of our app. So whether that's, which drivers do we dispatch to which passengers, or how do we match passengers together, how long will it take for a driver to get from point A to point B, all those kinds of things that are sort of critical to how the app functions. We work on all those things. But again, I don't know that that's a standard split. And even that split is not so black and white, because there are, data scientists, when they're launching new things, have to design experiments, run experiments, and kind of do, in some cases, pretty deep inferential analysis. So it's not really a clear line. I think at Google the line is also kind of blurry, but people who were hired as statisticians before data science existed are now called data scientists too. So I don't think there's necessarily a difference. I see data science as something like social science, where there's really a set of different disciplines that all feed into data science, and they're all, for example, on my team we have people from statistics, from pure math, from computer science, from physics, from operations research. So all of these different fields can, in my opinion, produce very capable data scientists. So it's more of a way of thinking and a space of problems with which to apply your skills, rather than like a discipline that you studied in school.
Agree. I can agree. At Facebook, there's also no clear line of what is an analyst and what is a data scientist. But here, at least for Facebook, people under the product org, meaning that people working on like adding new features to the app, deciding on what to do with Instagram or whatnot, they are called data scientists. Everyone on the business org are considered analyst or in analytics roles. But you get very similar background if you look at actually people's background. For example, on my team, we have like people with PhD in stats, we have PhD in other quantitative fields, but on the data science team, there are also people who do not have PhDs but have like experience in other industries and whatnot. So it's a blurry line, but the crux of it is, as Nick mentioned, to actually, it's more like a social science, data sciences area where you use like data to solve problems. Yeah, so I think that is where it's landing.
Thank you.
So, thank you. I think we have a few questions from the audience.
Yeah, our next question is, in addition to R, what software packages are useful to learn?
For me now, we use a mixture of R and Python, but it also depends on if like what is available in R versus what is available in Python, and also people coming from different background. But SQL is also something that is like a baseline. You actually need to know how to get the data before even doing any modeling on it.
Yeah, I can say Google and Lyft are very different in this respect. So at Google, R is very, very popular amongst, at least when I was there, amongst data scientists and statisticians, and to the point where there's like an engineering team that builds infrastructure for people to use R more effectively, and it's actually really great. And then like all the production code at Google is in like C or some language like that. So, you know, typically it would be engineers who would implement a lot of the stuff that, you know, data scientists and statisticians would build prototypes of. At Lyft, also at Google, like SQL type stuff was rarely used by my team. We did a lot of MapReduce instead. At Lyft, it's quite different. So we use SQL pretty heavily for, you know, we have less data than Google, so that's one reason. We also, our production code is written in Python, so we use Python for pretty much everything, both on the data science and engineering side. So that means data scientists can actually implement models in production quite easily, and which is great. So I would say Python and R are both really important things to know if you're going to consider a career in statistics and tech specifically. I think it can be dangerous to try to learn the latest and greatest like big data type thing, whether it's, you know, MapReduce or Spark or Hive or whatever the thing might be, because that'll probably change by the time, you know, you get through grad school if that's something you're going to do. So yeah.
So I've already said that I spend most of my day in R, but within my R scripts, there's SQL, so I can like get the data into R. So those two, like every day. And I wish, I wish that I knew Python as well. I kind of started a course, but there's so much other stuff to learn right now that it's kind of been on the back burner. Those three.
Awesome, thank you guys. Another question from the audience, from Azka Javad. Sorry, I definitely butchered that name. How important is a graduate degree for students who may be interested in technical management or senior engineer and data science roles in industry, as opposed to working in industry during those years instead?
I think at Google people would say that it doesn't matter. I'm not sure if it actually does. And Nick, you were here for a long time. Much longer than me, so maybe you have thoughts on Google as well as, you know, just in general where you are now.
Yeah, I mean, I think at Google, so it kind of depends what role you're looking for, I would say. I think software engineering, if you have a computer science degree from a good school, then you don't necessarily need graduate school. And then software engineering can then turn into other things. I think if you want to, and I think analytics type data science teams are similar to that. You typically see people having, you know, an undergraduate degree, maybe some consulting experience, maybe a master's in some cases. I think for the kinds of roles that are a little bit more, I guess, engineering heavy, but also kind of, you know, data science of the kind that my team is doing, we typically look for a master's degree at least when we're hiring people. That's not a hard rule. We've had people that didn't have master's degrees who were successful, but I would say that it's probably much easier to have to get into our recruiting pipeline if you have a graduate degree. And even with a master's, sometimes it's good to have a little bit of experience before coming here. So I think every company is different. I know some companies only hire people with industry experience. Other companies would only hire PhDs for their data science teams. So it varies quite a bit. I think the signal that I get when I see somebody has a graduate degree in a mathematical field is that I feel confident that they can sort of go deep on a problem and have a deeper understanding of the math underlying something. And so that kind of gives me confidence. On the other hand, if they have 5 years of industry experience at a company that's very relevant, then that's also an important signal. So.
Yeah, same here. So we have people from a mixture of different background. Our latest recruit, at least for the team I am on, our guideline is we hire PhDs with 1 year of experience or equivalent of internship experience, or we hire undergrads with 5 years of industry experience or masters with 3 years of experience. So that gives you a sense on if you're doing a PhD, we know that you can do hardcore research, you can take tasks independently, etc. But if you are in the industry for 5 years and showing that you have been doing very successful 5 years and doing very relevant stuff, it can also work out.
Awesome, thank you guys.
Cool. Our next question is that there's a standard response that is data science is the intersection of computer science, stats, and the domain knowledge. What do you guys think about that?
Thanks for giving me a definition in your question, because I had the same question.
I've also heard another one from Josh Wills, who's now at Slack, but who I used to work with at Google, who said that a data scientist is someone who can program better than any statistician, but who knows more stats than any programmer. Which is, I think people liked that because it was cute. But I think, I think that's obviously an oversimplification. So, I think that the intersection of computer science, statistics, and domain knowledge is also a little bit too simplistic. For example, as we mentioned, we have a lot of people on our team who focus on optimization problems, who have studied operations research, so kind of more on the applied math side. So that doesn't really fit into any of the buckets that were mentioned in that definition. But I think for a lot of transportation-related technologies, super important. So as I said before, I prefer to think of it as a diverse set of fields that can feed into one area. But I think the idea behind data science is more the type of problems you're working on and how you sort of think about taking data and turning it into a product.
Nothing to add. That's good.
Okay, cool, awesome, thank you. Another question from the audience is, do you guys have any advice for statistics minors who are majoring in psychology?
Take as much stats as you can. I love psychology, though. I actually was one class short of a minor in psych. Interesting stuff.
So I'm not really sure what you learn when you're doing a minor in psychology, but I guess sort of experiment design might be one, and surveys and things like that might be one aspect that is taught, or that aspect of statistics that is sort of relevant to psychology. And I think I've gotten a kind of a new appreciation for the importance of experiment design since coming into industry. It's kind of the course in grad school that nobody really cared that much about or was super interested in, but it's actually pretty subtle, and especially being at Lyft, which is a kind of a very complex two-sided marketplace. Designing rigorous experiments that allow you to estimate things in an unbiased way is actually a lot harder than it sounds. So that's one thought.
Yeah, really good call out on the experiment design. This is something that we like think about day in and day out, especially when you have like small sample size with a sales team and you still want to test out something in a short period of time and the stake is high. How would you design it? So I think the psychology coursework may be of some help here. I think it really depends on what you want to do. If you want to get into data science or get a role that's more like stats or math relevant to that, you can do side projects, you can do Kaggle, you can just and try to do more internships in the areas that you're really interested in and start from there.
Well, thanks. Our next question is, what are some of the toughest challenges that you face in your job and how do you tackle them?
I feel like I'm always starting, so feel free to cut me off. Well, I kind of alluded to one, which is the challenge of designing good experiments. So I can elaborate on that a little bit. It's a technical challenge we face. The reason it's hard is because most tech companies like Google and, well, okay, Facebook actually has its own challenges, but take Google, for example. It's relatively straightforward to just, randomize users into treatment or control, and, they have tons of queries, so they can just measure the impact of whatever change they're testing by diverting the two groups to different sort of code paths. The reason that's hard for us is because our users are always interacting with each other. For example, if two people are trying to request a ride and they're standing right next to each other, then they'll be competing for the same set of drivers. And so it's hard to cleanly separate users into different buckets. And Facebook has a similar problem because they have a social graph and users, again, interact socially with one another. So that's a problem that's actually required us to develop some methodology to solve it in a more clever way by doing different types of designs and different types of randomizations that are not necessarily user-based. And then you have some really interesting statistical problems around bias variance trade-offs and so on. So that's a technical challenge that we've had to face. Other challenges I face daily are just hiring people, hiring especially experienced data scientists or statisticians, from hiring people away from Facebook and Google, which is really challenging because those companies treat people really, really well. And also hiring people that have experience managing data scientists. So those are some of the challenges I face.
I'll speak less about the technical challenge, but more about, I think, especially transitioning from consulting to the industry. One challenge I do face is that there's more ambiguity. There's no one to tell you what exactly you're actually going to do, and you can do a lot of stuff. Your assignment can be, hey, go figure out, try design a new sales initiative and our goal is just to increase revenue. And you have yourself, you have your program manager, and you can tap into different teams and resources to figure that out. Come up with a design, come up with your KPI, and convince us to give you a resource to do that. So there's a lot of ambiguity involved. So it's more about how do you step back and understand the context and understand what are the small questions that you need to answer this bigger question, and how do you execute on it. It's a whole suite of things that you'll need to do. So that I find, and within it there will be technical challenges throughout. So, but the whole ambiguity is what I find pretty tough, but also interesting at the same time.
So I would say that there are always shortcomings in the data, and I'm always and trying to figure out how it impacts any insights that might come out. If I'm often not the one, I'm jumping in after the data collection has already been designed. So just trying to give the best answers I can with whatever data I'm given. It's always a challenge, but can be fun.
Awesome, thank you guys. So there's actually one question, and okay, now we have 1 minute. So anyone just briefly answer it. Just any advice on what undergrads should do during the summer?
internship, internship, read, and talk to different people in different areas you may be interested in, and really hone in on communication skills. People in the tech, science background may be more willing to develop all the technical skills, but communications is also really important.
Cool, awesome. Thank you so much, Nick, Ann, and Chandra, for being on this panel, and thanks to all our listeners. Bye. Thank you.
Thank you. Have a good weekend.
Thank you. Bye.
Bye.